Geotechnical Engineering Part A, Soil Mechanics, Chapter 8, Seepage. If we want to construct a flow net over a dam with the upstream of H1 and downstream of the dam with H2 height of water, let's see how we can approach this problem to construct the flow net. As you can see, the soil beneath the dam. So let's define some terms. First of all, flow line. So flow line is the path which a drop passes by traveling from the higher head to the lower head. So if we just consider H1 like the bigger chunk of water, like higher head, like H1, and the other one is H2, which is the lower amount of water head. And if we just assume we have a droplet from here, this droplet wants to travel all over the places to reach to the lower head. This is higher head of water, and this is the lower head of water. Pass which a single droplet travels to reach to the lower level from the higher one, called flow lines. So each of these line stands for, each of these blue line stand for flow line, because water can travel from the higher level, from the left side of the dam to the right bank, which is the lower head, and they are the flow lines. Each of them are a single flow. And then the tangent to the path in each location is the direction of velocity. So this is Vi, and this is the hydraulic gradient. So that's the velocity, and this is the vector of gradient, and they are perpendicular paths, perpendicular to isopotential line and tangential to the flow lines. And let's define another term, which is isopotential lines is the locus or location of all points which are having the same head. So if you look at this curve, red line, they are, for example, if we have a potential of 10 in all location on this path, we have a 10 meter of waterhead. Doesn't matter which side you stand. That's the meaning of isopotential. So for example, if this line is 9, have 9 meter of waterhead each location, and that's the locus of all points which are sharing the same amount of waterhead. It can be a straight line, or a curved line. They are isopotential. We call them isopotential lines because all points standing on them having the same amount of water. And definitely, as you travel farther from the upstream to downstream, the head of water is decreasing from 10 to 9, 8, whatever it is. And the formula for that is, you can define delta Hi. Each drop between each of these lines is delta H total. Subtract H1 numeric value minus H2 numeric value of H2 over the number of drops. That's the delta Hi in each drop. It's just this the amount for each of delta I is the total head of water over number of drop. So we talk about it later, and also this charge is hydraulic conductivity K times number of flow over number of drop times delta H total. Talk about this one in detail as well. So for example, let's put it to a unique example. If we have H1 equal 14 meters of water in upstream of a dam, and we have H of water like H2 like 2 meters of water in downstream side of a dam. Again, we call each of these part a flow pass, So this is a flow pass, a channel, a channel, a channel, a channel. And also each of these in red curved line are isopotential lines. So if you just assume 2 points like A and B, for example, delta Hi is delta H total over number of drops. So if we call this point A by the height of 10 meters from the soil, that's B in the height of elevation, depths of 11 meters down from the soil beneath. If you want to calculate delta Hi, you simply 14 minus 2 higher head H1 minus H2 over the number of drops. So this is our first initial head. So this is our first drop. This is 1. This is 2. The second isopotential line. This is 3. This is 4, 5, 6, 7. And also all the way to the downstream. Number of drops are 8. So number of drops just goes to denominator. Over here just goes to our denominator, and it just gives us 12 over 8, which is 4 over 8, 12 over 8, which is 1.5 meters. Each of these drops is 1.5. So if we want to construct the first drop is from 14 to second one, which is 14 minus 1.5, just counts us to drops from 14 to 12.5, then 12.5 minus 1.5 is 11 and 9.5, 8, 6.5, 5, 3.5, subtracted one more head loss to reach the downstream, which is the initial head at downstream. And if you want to calculate, for example, H at A, just assume A is located with the same amount of distance. This is at the center of this pass amongst these two potential line, isopotential lines. So 12.5 plus 11 over 2 just gives us HA, that's 11.75 at the center between these two isopotential lines, 12, 1 and 11. Just simply average them and just reports like HA, which is 11.75 meters. And likewise, if you want to calculate HB, this is 5, and just assume this is a 1/3 from the isopotential line of 5 and 2/3 from isopotential of 3.5. So if you calculate the head loss from 5, you have to calculate it. HB is 5 minus 1/3, because we are subtracting one of his times 1.5, which is each of the drop. That gives you 4.5. You can start it from the other side. So that's a 3.5 plus 2/3 of 1.5. It just gives you the same value. In next videos, we talk about more problem. Seepage. Thank you.